welcome back to this channel. In this video, we are going to focus on calculation for the part of chemical equilibrium, which we will going to calculate the Kc, Kp, or the concentration, pressure of certain species at equilibrium, which we may use ice table. Then we also will going to determine the degree of dissociation at where it is changed over initial. Then we are going to predict the direction of the net reaction by comparing the reaction quotient and the equilibrium constant. Let's continue with tutorial question number 10. 0.1 mole SO3 introduced. With this keyword, we know this is the initial number of mole, and then we place into a 1 liter flask. Then the reaction will proceed based on here. When the equilibrium is reached, the amount of SO3 is 0.07. So once we have the information about initial and equilibrium, basically we know that we are going to use ice table. So if we want to use ice table, we have to make sure either the unit is in number of mole per liter, or ATM pressure. So in this case, how we going to determine which unit we are going to use in the ice table? Maybe we can refer to question A. Calculate the concentration, the equilibrium concentration of SO2 and O2. So basically, we are going to know, because the question is asked us look for the concentration, then it will be better the ice table, all the information substitute in are in the mole per liter. So now let's calculate the initial concentration for SO3. As we know, molarity is equal to mole over volume. So in this case, initial concentration of SO3 is 0.1 divided by 1. Because of the volume is 1 liter, so it will be very easy for us, 0.1. And then when we go through the question, there is no mention we are putting SO2 and oxygen in the flask. So that means the initial concentration for SO2 and oxygen are 0. Then now we look at the change part. So based on this question, yes, this reaction can go forward and also backward. But if initially you only have SO3, so means that the reaction is going to move to the right. So when the reaction moving to the right, we will notice that the concentration of SO3 will getting less and less, while for the SO2 will getting more and more. But how much or how many of them is going to increasing, we have no exactly value given in the question. But we know that the ratio for the SO3 is 2x, while for the SO2 also 2x, and oxygen is just 1 part only, so it is plus x. So then next we go to equilibrium. So for the equilibrium, the information is given over here, which the amount of SO3 is 0.07. So if we divide by 1, so it will also equal to 0.07. So, and then for the concentration SO2 will be 0 plus 2x, so basically it's equal to 2x, and oxygen 0 plus x basically is x. Okay, then if we are going to write this one in the unknown, so for this part, equilibrium 0.07, if we combine the initial and change column, so it will 0.1 minus 2x. So basically then we will mention that 0.1 minus 2x basically is equal to 0.07. So x is equal to 0.15, but we haven't answered the question yet. Okay, because the question is asked us look for concentration SO2 and concentration O2. So concentration SO2 at equilibrium is equal to 2x. So when you press the calculator, you will get 0.03 molar. while for the oxygen at equilibrium is equal to X, so which is equal to 0.15 molar. Question B. Determine the equilibrium constant Kc at 900 Kelvin. Based on answer in question A, we have idea the concentration for SO3 at the equilibrium is equal to 0.07 molar, while for the SO2 is 0.03 and O2 is 0.015 molar. So before we can calculate the value of the equilibrium constant, we need to write down the Kc expression. Since all the physical states are gas, so all these species will appear in the Kc expression for using the product over reactant. Concentration of product SO2 with the power of 2 multiplied with concentration oxygen with the power of 1 divided by concentration of SO3 to the power of 2. So concentration SO2 is 0.03 to the power of 2 multiplied with 0.015 and then divided by 0.07 to the power of 2. So when you press the calculator, you will get the answer is 0.00276. So this is the Kc value for this reaction. Then let us proceed with question part C. Calculate the degree of dissociation. So basically, when the question asks us to write to determine the degree of dissociation, the symbol is alpha. So you can give them in terms of fraction, decimal places, or you also can give them in percentage. Means that it is not specific, so you can give it either one of these form. So what is the meaning of dissociation? In Bahasa we call like penguraian. So basically, reactant or product undergo dissociation. Basically, if you refer to this reaction, the reactant is undergo dissociation. So we want to know how much is dissociate. So means that we are going to refer to the change and then we are comparing to the initial. So if let's say I want to calculate the percentage of dissociation, so then it will be equal to change of reactant over initial concentration of reactant multiplied by 100%. So the change of concentration of reactant SO3 is 2x. And where just now we know that x is 0.015, so 2x means is 0.3. Sorry, 0.03, while the initial concentration of the SO3 in this case is 0.1. Then we multiply by 100%, so it will equal to 30%. Question 11. 25 grams of carbon dioxide gas react with hot carbon in the form of graphite to produce carbon monoxide gas in 2.5 liter. So the equilibrium constant given is 10 at 880 degrees Celsius. So now the question is asked us to write the equilibrium reaction. So from the question, it is very obvious that carbon dioxide gas is the reactant and also the carbon. So because of the carbon is in the form of graphite, so we know that the physical state for the carbon is solid. And then because this is an equilibrium constant given, means that this is a reversible reaction. So we are going to use reversible arrow to produce carbon monoxide gas, so CO gas. Then we have to balance this equation. There is 2 carbon and 2 oxygen, so means that it will produce 2 more of carbon monoxide. So this is answer for question A. Then next one, we are going to continue with part B. Calculate the Kp at 880 degrees Celsius. So if we look at here, there is no information about pressure. Okay. But then we are given the Kc value. So we given the Kc value and ask us to look for the Kp value. which is the question mark here, then we can use the formula Kp equal to Kc RT delta N. So Kc given in the question is 10, while the Kr is 0.08206. Temperature given in this question is 850. So we are going to convert to unit of Kelvin, 273. And then this RT, we need to go for the power here. So the delta N is the number of mole of gas, for the product minus reactant. So in this case, we have 2 mole of product, so we will use 2. And then even though here we have 2 reactants, but only 1 reactant are in the phase of gas, so we are going to minus 1. So then you press the calculator, you will able to get the answer 921.534. Proceed with tutorial question number C. Calculate the initial pressure in the container. So means that we need to know the pressure. And then as we know, the pressure only will asserted by the substance of in the physical state of gas. So in this case, we have carbon dioxide gas as the reactant. So means that we are going to look for the partial pressure of the carbon dioxide. So and then because this is a gas, so we are going to use PV equal to nRT. So do keep in mind that the N over here, because we are looking at the partial pressure of carbon dioxide, so the N here is referred to carbon dioxide of the number of mole of carbon dioxide as well. So we rearrange this formula. So partial pressure of carbon dioxide will equal to number of mole of carbon dioxide RT over volume. So how we can get the number of mole of carbon dioxide? In this question, they are not give us the number of mole, but they give us the mass of carbon dioxide. So we are going to use 25 over 44, which is the number of mole, and then R again is 0.08206, and then the temperature 850 plus 273 is 1123 Kelvin over the volume. The volume given here is 2.5 liter. So after you press the calculator, you will be able to get the answer. Let's continue. Question number D. Calculate the pressure of its gases at equilibrium. So in previous question, we're looking for the initial. At this question, we are going to look for the equilibrium. So means that we are going to use istable. So if we need to use istable, in this case now, we are going to make sure the unit is in atm, because we are going to determine the value of the pressure. So in part C, we already calculate the initial concentration of carbon dioxide is 20.937. For the carbon, because it is solid and it will not appear in the Kp expression, so we will ignore the carbon. While for the carbon monoxide, initially we didn't produce any carbon monoxide into the container. Means that the concentration, the pressure that will be asserted by carbon monoxide is equal to 0. Then, because in the container only consists of carbon dioxide and carbon, so the reaction will going shift to the right. And then because of shift to the right, then we know the amount of carbon dioxide is getting less and less, while for the carbon monoxide is getting more and more. So how much is the changes? So we have no idea. So but then we know the ratio is 1 to 2. So that's why we are going to use minus x plus 2x. So when the reaction achieves equilibrium, the partial pressure for the carbon dioxide will become 20.937 minus x, while for the for the pressure of carbon monoxide will be 0 plus 2x. Next one, we are going to determine the gases. So the information that we have is the Kp. Okay, basically after we write the ice table, we are going to proceed with either Kp or Kc according to the question. So in this question, we are going to use Kp equal to partial pressure of carbon monoxide raised to the power of 2, while partial pressure of carbon dioxide raised to power of 1. By substituting the value in the expression, so we are going to know that because of value of Kp is given in the question, which is, it's not given in the question, but we calculated in part B, which is 921.534. So equal to partial pressure of carbon monoxide 2x squared, and then over partial pressure of carbon dioxide 20.397 minus x. So this one will become the quadratic equation, and where it will equal to 4x squared plus 921.54x minus 19294.157 equal to 0. So by pressing the calculator, we will able to get two values of the x. One of them is 19.317, while another one is negative 349.70. So we know that this one is the x value is referred to the pressure. So pressure never in the negative value. So we will say this one is not accepted. Okay, due to pressure never in negative value. So same case will happen to the pressure. The concentration also never in negative value. Okay, then now we haven't solved the question yet because we are going to look for the concentration for each gases. So we have two gases here, so we need to find out what are the gases for partial pressure at equilibrium. What is the partial pressure for carbon dioxide? So we're going to use 20.937 minus 19.317, which is equal to 1.62 atm. Okay, while for the partial pressure of carbon dioxide is equal to 2x, so it's 2 multiplied with 19.317. Press the calculator, you will going to get 38.634 atm. Next question, we are going to answer question E. Calculate the total pressure at equilibrium. So from the term total pressure, basically we know that the operation, mathematical operation here will be is sum up. Okay, so at equilibrium there is only carbon dioxide gas, which just now we calculate is 1.62 atm, and then another gases is carbon monoxide. So the partial pressure that we calculate in the previous slide is 38.634. So now when you sum up these two values, it will equal to 40.254 atm. Next question is F. On the same graph, okay, so the keyword over here is same. Sketch the variation of the pressure of carbon dioxide and carbon monoxide against the time. So means that we are going to plot the graph, which is pressure. Don't forget the unit. Then next is the time with the unit of second, or any unit that you think is suitable, because in this question they didn't let us know what is the time that this reaction achieves equilibrium. So we can put either any unit of the time. Then we need to start with the, let's say you can start with either carbon dioxide or also carbon monoxide. Okay, but because we know that carbon dioxide is the reactant, so the partial pressure of carbon dioxide is getting less and less. So initially, let's say over here is initially the concentration is 20.937, so it's getting less and less. When achieve equilibrium, the pressure is become 1.62 atm. Okay, but for the partial pressure, so this one you can label, this is carbon dioxide, while for the carbon monoxide, the pressure, because the carbon monoxide produce more and more, so the partial pressure from the that asserted from the carbon monoxide also is getting more and more. So just now we already determined when achieve equilibrium, the partial pressure of carbon monoxide is 38 something. So that's I know that when I sketch this graph from the origin, it will increasing and then it will cross over with the line for the carbon dioxide, and then let's say this one here, you will going to label this is 38.634. So and then over here you just draw one line and then say achieve equilibrium. So we know that after this time the reaction is achieve equilibrium. Question number 12. In a 12-liter vessel, chloromethane is formed by the reaction based on this equation. So given the Kc value is 1.6 exponent 4 at 1230 degrees Celsius. If the reaction mixture starts with CH4, Cl2, CH3Cl, and also HCl. So as we also know, start means it is referred to initial. All of these are given in number of mole, but the question is asking us look for the concentration for each reactant. So again, when we want to calculate the concentration, we are going to use number of mole over volume. So the volume given in this question is 2 liter. So by using 0.26 divided by 2, the concentration of CH4 is equal to 0.13 molar. While for the concentration Cl2 is equal to 0.035 molar, and concentration Cl2 equal to 0.24 molar, and concentration HCl equal to 0.45 molar. Since all here are referring to the initial concentration, so normally we can write a I next to the bracket of square bracket here to represent this is the concentration for initial concentration. Next, question B, we are going to calculate the reaction quotient. So why in this question we are going to calculate the reaction quotient? If you compare to question 10 and 11, for question 10 and 11 we only have substance at the right hand side placed into the container. Okay, so that means we directly have the idea. We know that the reaction is going to shift to moving to the right side. But for this question 12 here, all the reactants and products are given. So means that we mix all of them at the same time. So if like this, there are two possibilities whether the reaction is at equilibrium or not at equilibrium. Okay, so that's why we are going to calculate the QC. Okay, as long as in the question they didn't say this is the concentration at equilibrium, means that if we want to do the calculation, we are going to calculate either the QC or KC, QC or QP, which is referred to reaction quotient. So QC for this reaction, actually the way we write QC is exactly same as the KC expression. Okay, only when we write KC we confirm that the concentration that we substitute in is at equilibrium. But now because we are not sure whether the concentration given over here is at equilibrium or no, so we are going to use QC. So product CH3Cl, so means that it's referred to this is CH3Cl. CH3Cl is 0.24 CH3Cl multiply by concentration HCl divided by concentration CH4 and concentration Cl2. So CH3Cl is 0.24, concentration HCl is 0.45, while CH4 is 0.13 and Cl2 is 0.035. So when we press the calculator, we're going to get the value 23.74. So this is the answer for B. Question C, next we are going to determine the reaction will going to shift to the left hand side or right hand side in order to reach the equilibrium. So when we want to answer this question C, we are going to compare QC with the KC. Okay, so the value for the QC is 23.74, while for the KC is 1.6 exponent 4. So QC and KC are not equal, so means that they are not at equilibrium. And then if we compare which one is greater, the value of 1.6 exponent 4 is greater. So that means we are going to know this reaction now at this moment, they are going to shift to the right to achieve equilibrium. Question D. Calculate the concentration of each reactant and product at equilibrium. Okay, so in the previous question, we already determined the initial concentration, and then this time they asked us to look for the equilibrium. So again, we know that for this question, we are going to use ice table. So then we are going to make sure the unit in the ice table is mole per liter. So we just place the answer that we determined in question A, and then we put at here CH4 0.13, Cl2 0.035, CH3, Cl 0.24, and HCl is 0.45 molar. So and then for your information, because initially both reactant and product are present, so we have to decide whether the reaction is going to shift to the right or shift to the left. So then based on the answer in part C, we know that the reaction is shift to the right. So if the reaction is shift to the right, that means amount of the CH4 is getting less, Cl2 also getting less, but CH3 and HCl will getting more and more. Okay, so based on the chemical equation over here, the ratio is 1, 1, 1, 1. So that's why it's minus x plus x plus x. So and then we have the at equilibrium. So this one will be 0.13 minus x, 0.035 minus x, 0.24 plus x, 0.45 plus x. So here we notice that when at the equilibrium here we have an unknown, so we are going to solve it using the Kc expression. So Kc is equal to concentration HCl multiplied with the concentration Cl2 over the concentration CH4 multiplied with concentration Cl2. So once we press the calculator, okay, because the value of Kc given, and then the concentration at equilibrium is in the row of equilibrium in the ice table. So basically 1.6 exponent 4 equal to 0.45 plus x multiplied with 0.24 plus x divided by 0.13 minus x, 0.035 minus x. So press the calculator, you will notice that the x value that is showing over here is x1 equal to 0.1301, while x2 is 0.0349. So between these two values, there must be one value is invalid. Okay, so how we're going to know whether which value is valid or invalid? Basically, we try to substitute the value into the unknown here. as we already know that all these are referring to the concentration, so I take this one, the smallest value, for example, this 0.035 minus x. So if the x value is 1, 0.035 minus 0.1301, we will get the negative value. So, and then just like mentioned just now, the concentration never in the negative value. So we know this is invalid due to concentration cannot be in negative value. Then we are going to use this value 0.0349, which is valid, into all these calculations over here. So, and then we will notice at equilibrium, the concentration of CH4 is 0.0951 molar, and then this one is 0.0001, and this one is 0.2749, and the concentration of HCl is 0.4849. Okay, this question 13 basically is quite similar with the previous question 12. Only maybe when you read this question, you will notice this time they are given us the Kp value, and then because of given Kp value, so the partial pressure of each gas is given. Also, all the reactant and product are given. So, and then the question is asked us, is the system at equilibrium? If not, so it will go to which direction? Okay, then only we calculate as question 13, as question 12 again. They ask us each reactant and product when the system achieves equilibrium. So before we can continue, again, because we want to determine whether it is at equilibrium or no, so pressure is given, so we are going to calculate the Qp. The way of writing the Qp expression and Kp expression again is exactly the same. So partial pressure of hydrogen iodide multiplied with the power of 2 over partial pressure of hydrogen gas and partial pressure of iodine gas. When you substitute the value into this formula, so iodine is, Hi is 0.015 to the power of 2. Hydrogen and iodine is 0.05 respectively. So press the calculator, basically you will get the value 0.09. Okay, so because the question wants us to know whether it is at equilibrium, so you can compare the Qp with the Kp value. So Qp is 0.09, Kp given is 4.18 exponent negative 3. Okay, so Qp and Kp is not equal, but then we know at the same time, after we know that they are not equilibrium, so we need to know where is the direction, whether the reaction is going to move to the left hand side or to the right hand side. So when we compare the value here, we will notice that Qp value is greater than Kp. So with this, we know that the reaction is going to move to the right, move to the left, or we also cannot, the reaction will move backward. Proceed with this part. Calculate the pressure for each reactant and product when achieve equilibrium. So from the question here, we already have the idea for the initial pressure for each of the reactant and product, which I already placed it here. And then just now when we do for the question which direction, we know that the direction is backward reaction or move to the left. So if move to the left means that the amount of the Hi is getting less, while iodine and hydrogen is getting more. So the ratio is 1 to 2. So this one we are going to plus x, and then Hi will go into minus 2x. So if we want to know the equilibrium pressure, so for Hi is 0.015 minus 2x. So this one is 0.05 plus x, and this one also 0.05 plus x. Then because of we need to calculate the x value, then only we can able to write the determine the exact value. of the pressure at equilibrium. So means that we're going to write the Kp expression, where in this case is partial pressure of hydrogen iodide to the power of 2 over partial pressure of the hydrogen multiplied with partial pressure of iodine. Okay, so maybe some of you will ask, but the question now is a backward reaction. So is Hi is the reactant, but don't forget this Kp value given over here is based on this equation. If you still remember in the tutorial question number 5, if the position of the reactant and product is at different side, the value of Kp or Kc will be different. So because of the Kp value mentioned follow the reaction which given here, so we still will write the Kp expression based on this equation. Okay, so then the Kp value is 4.18 exponent negative 3 equal to partial pressure of Hi 0.015 minus 2x to the power of 2, and then 0.05 plus x. Since both pressure of hydrogen and iodine are similar, so I can also to the power of 2 over here. So since both of these are power of 2, so we can make square root at both sides, so that we will not use a quadratic equation. When you make the square root at both sides and then you try to solve this mathematical problem, you will get the x is equal to 0.0057. So this question is asked us to look for the pressure for each reactant. So that's why we are going to find it one by one. So partial pressure of hydrogen at equilibrium is same with partial pressure of iodine at equilibrium. So we can do it once only. So it's 0.05 plus 0.0057. So which is equal to 0.0557 atm. While for another partial pressure of Hi at equilibrium is equal to 0.015 minus 2x. So substitute the value in, you will get the final answer at equilibrium is 0.036 atm. Now let's continue with simple step that we need to know when we want to solve the question about ice table. First, we need to have an ice table. So how are we going to determine whether the question needs to apply ice table? Basically, if in the question you notice that you are given information about initial and then ask you to look for the equilibrium, means that we're going to use ice table. Then the unit for the ice table can either in number of mole per liter, or it also can be in atm. Next, you will base on the information in the question into the ice table. Then you will notice that in the ice table there are x value. So to solve this, and then basically we need to look for the value at equilibrium. So we're going to write Kp or Kc expression. Then substitute the value into from the ice table into the equilibrium law. Then we will going to get the x value. So sometimes this time, most of the time we will get the quadratic equation. So if it is quadratic equation, basically we will get two x value, x1 and x2. So you have to decide which one is valid or invalid. Okay, basically if invalid means that after you substitute the value into the equilibrium row, one of them will be in negative pressure or negative value of the concentration. Okay, which negative value is not accepted for pressure and also concentration. So then we will, after we get the x value, we choose either one of these. x1 or x2, and then we will substitute into the question and then change to quantity that required in the question. In this video, we also discuss a bit about the degree of dissociation. So do remember that dissociation in Bahasa is called terurai, or in another term we can say is decompose. So among the reactant and product, reactant will be decomposed. So we always will use how much of the reactant that decompose compared with the initial. Okay, so basically is of reactant. Okay, so if they mention degree of dissociation, you can either place them in terms of fraction, decimal, or also in percentage. Okay. Then the third type of the question is which will be involving the reaction quotient, either is QC or QP. Okay, basically if in the question you have no idea or you're not sure whether the reaction is at equilibrium or not at equilibrium, you can use the QC or QP expression. The way we write QP or QC expression exactly similar with KC and KP expression. So if QC is not equal to KC, so means that it is not at equilibrium. Okay, when this is not at equilibrium, then we have two possibilities. If the QC is smaller than KC, the reaction will shift to the right to achieve, not shift to the right, that means the reaction is moving to the right to achieve equilibrium. Another way, if the QC is more than KC, means that the reaction will go to the left to achieve equilibrium. So that's all for the part calculation. Okay, here are the final answer for tutorial question 10, 11, 12, and 13. So thank you for staying up to end here. So hopefully you can get some idea from this video. Thank you. See you in next video, which will discuss about Le Chatelier.